To determine if a table is direct variation or if y varies directly with x, you want to see if y divided by x is the constant, because that's called the constant of variation. So what I'm going to do in this table is I'm going to divide y divided by x and see if all those numbers are the same. Now, I keep away from 0 divided by 0 because that's just a special case, but when I divide 1.2 by 1, 2.4 divided by 2, 3.6 divided by 3, I get 1.2. So that means, yes, it's direct variation. And then the k is 1.2. So my equation is y equals 1.2x. Because direct variation is y equals kx. So we're finding our k. So for the second table, I'm going to divide this, and I get 2. I divide this, I get 1.5. I divide this, I get 1.3 repeating. I divide this, I get 1.25. So these are all not the same. So this is no, it's not direct variation. So I'm not going to write an equation for it. And the last one, if I divide 20 divided by 2, 40 divided by 4, 60 divided by 6, I get k equals 10. So yes, k is 10. So the equation is going to be y equals 10x. Okay, for 2 and 3, suppose y varies directly with x. So that means you can write an equation y equals kx. Now I'm going to use the second part of the equation to solve for k. When x equals 3, y is 27. So 27 equals k times 3. So that means that k equals 9. So when it reads to write an equation for the variation, your equation needs to have an x and a y in it. So I already solved for k, so my equation is going to be y equals 9x. And then the last step is find y when x is negative 5. So plug in negative 5 for x. So this is going to be negative 45. So the process is you want to write a general equation, y equals kx. You want to use the information to solve for k. So 2.8 equals k times 1.4. So k is 2. So my equation is going to be y equals 2x. And then find y when x is negative 3.6. So I'm going to do y equals 2 times negative 3.6. So that's negative 7.2. Okay, number 4, write a direct variation equation for each ordered pair. So in direct variation, up here, k is y divided by x. And your equation is going to be y equals kx. So if I have an ordered pair, make it simple, I'm going to do y divided by x, because I'm trying to figure out what I multiply x by to get y. So k is 4. So my equation is y equals 4x. So this one, k is 2/3. So my equation is y equals 2/3 x. Negative 7.2 divided by 6 is negative 1.2. So y equals negative 1.2x. And then your k would be 2, so y equals 2x, because y divided by x is k. Okay, number 5, write an equation for the line of best fit, round the nearest tenth. So we're going to round each of them to the nearest tenth. So what you need to do is you need to put the x values in your L1 and your y values in your Y2. So you get that by pressing the stat button. So stat, edit. So I'm going to go to stat, edit, and then I'm going to fill in 12, 12, 14.5, 15.7, and 17.2 in for my L1. And my L2 directly across from it, so 12 goes with 12, 12 goes with 15, 14.5 goes with 16, 18.9, and 22.3. So once you put this in, you want to go to Stat, back to Stat again, Calc, and then Linear Regression. Look for LinReg. So Stat, Calc, Linear Regression. Press Enter all the way through until you get your A and your B. So I'm going to round my A to nearest tenth, so it's y equals 1.6x. And my y-intercept, my b value, is negative 6.2, and I rounded. So find your equation to find, or use your equation to find y when x is 20. So I'm going to plug in 20 in for x. So 1.6 times 20 minus 6.2, and that's going to give me my y. So 1.6 times 20 minus 6.2 is 25.8. Okay, a hot air balloon is descending at a constant rate. After 1 minute, the elevation is 320 feet, and after 3 minutes, the elevation is 270 feet. Write a linear equation to model the balloon's elevation after minutes t. So if this question is asking us to use these variables. So we're using E for elevation and height, or elevation in feet, and T for minutes. So when you have to write ordered pairs, you need to think about what's going to be your independent variable and what's going to be your dependent. So independent variable is always a time. So 1 minute, the elevation is 320. 3 minutes, the elevation is 270. This makes sense because the hot air balloon is descending. So you can find the slope and write it in point slope form. I'm just going to use my calculator and go to Stat, Edit, put L1 is going to be 1,3, and L2 is going to be 320 and 270, and I'll have an equation for my function. So it's going to be Stat, Edit, delete the old ones that you already did. So I'm going to put in 1 for L1 and 3 for L1, and then 1 maps onto 320 and 3 maps onto 270. So again, you press Stat, Calc, Linear Regression, and my equation is going to be, my A is negative 25. So because my elevation is descending at a constant rate, that's my slope, and my y-intercept is 345. So that means the balloon started at time 0 at 345 feet high. So my equation using E and T is going to be E equals, the elevation equals negative 25t, because we have to use in t minutes, plus 345. Okay, 7, graph each function and write the features of the graph. So the vertex is going to be at -4, -2. So whatever is with the x is always opposite, and the y value stays the same. So I'm going to make my vertex at -4, -2. And then my slope is 2. So I'm going to, from this point, I'm going to go up 2, right 1, up 2, left 1. And I'm going to continue that pattern. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And go the other way too. Up 2, left 1, up 2, left 1. So my x-intercepts are going to be at -3 and -5. So I don't want to write it. A common mistake is for people to write -3, -5. That's an ordered pair. Okay, if you write those two parentheses like that, that's an ordered pair. So I'm going to write it as -3, 0 and -5, 0. So those are the two ordered pairs represented. And my y-intercept is at 0, -6, or 0, +6. Okay, another one. The vertex is going to be at +3, +1. And then my slope is -1, because that's a number in front. So I'm going to go down 1, right 1, down 1, left 1. Keep going. So my x-intercepts are going to be at 2, 0 and 4, 0. And my y-intercept, where it crosses the y-axis, is at 0, -2. Okay, a couple more graphs here. So I'm going to do my vertex is going to be at -6, -3. So left 6, down 3. And my slope is -1/3. So I'm going to go down 1, right 3, down 1, right 3. Like this. So my x-intercept, if there's not going to be any x-intercepts if it's opening down, it will never cross it. And my y-intercept is going to be at 0, -5. And my vertex for this will be -2, +1. So I do left 2, up 1. And my slope is 1. So I'm going to go up 1, right 1, up 1, left 1. So the x-intercept, none. It's not going to cross the x-axis. And the y-intercept is going to be at 0, 3. Okay, 8, 9, and 10 is about the transformation. So write an equation for the absolute value of x after it's been shifted up 3 and left 4. So it's going to be y equals, there's no vertical stretch at all. So it's going to be left 4 is going to be x plus 4, and it's shifted up 3. Okay, number 9, it's only been reflected across the x-axis. So that means the slope is going to be -1. So -1 needs to go outside. So it hasn't been shifted left, right, up, or down. And then 10, you're shifting it down 3 units. So it's absolute value of x -3.